What do you do when your city confirms you have a lead service line, but the lab test you run doesn't detect any lead? That was the situation facing one of our customers in Colorado. After receiving a letter from the city about potential lead contamination and being issued a pure pitcher as a stopgap, they wanted a long-term solution to protect their entire home, not just their drinking water. So we installed a full point of entry system from US Water Systems, including their triple-stage cartridge filter and Bodyguard fluoride removal system. Then we ran 2 rounds of independent lab testing before and after the system was installed to see exactly how well it performed. In this video, I'll walk you through the test results, what surprised us, and what we learned about managing disinfection byproducts, fluoride, and the hidden risks of lead, even when it's not detected by a water test. Before we get into pricing and performance, let's talk about the real-world situation that led to this install, because it's something that more and more homeowners are dealing with. This home in Denver, Colorado, was flagged by the city as having a confirmed lead service line, part of a broader lead reduction initiative. The homeowner received an official notice and was sent a pure pitcher to use for drinking water as a temporary safety measure. The city's plan is to eventually replace the lead line, but until then, there was a very concerning question: what's actually coming through the tap? We ran an independent lab test through TapScore, and interestingly, no lead was detected in the water samples taken from the kitchen faucet. Still, that didn't mean the risk had been addressed. Lead release can be inconsistent and influenced by things like water chemistry, temperature, and physical disturbance of the pipe. Just because lead wasn't detected on that day doesn't mean it won't show up tomorrow, especially when the service line is confirmed to be made of lead. So we looked a little bit closer into what the city was doing on the treatment side. Some municipalities use orthophosphate to coat the inside of old lead pipes and prevent corrosion, but Denver Water uses a different strategy. Instead, they raise the pH of the water to make it less corrosive. It's a valid approach, but it doesn't physically remove the lead pipe itself, so there's still some level of uncertainty. That's what drove the decision to install a point of entry filtration system, not just for lead protection, but to reduce a broader range of contaminants commonly found in city water. The customer initially preferred a cartridge-based system for easier maintenance, and based on our initial test results, US Water Systems recommended their Magna Compact PoE cartridge filter, which targets sediment, chlorine, disinfection byproducts, and heavy metals like lead. Later, we added a fluoride filter downstream to round out the system and provide broad spectrum protection across all taps in the home. So with all that in mind, a confirmed lead service line, fluctuating water quality, and the need for broad spectrum protection, let's look at what a system like this actually costs. The first system we installed, the US Water Systems Magna Compact Whole House Cartridge Filter, runs just under $900. Because the system uses replaceable cartridges rather than a tank filled with media, you avoid the higher upfront costs that come with larger tank-based systems. Cartridge systems are generally more affordable upfront and easier to install and maintain, but there's a trade-off. The filters need to be replaced more frequently, which means slightly higher long-term maintenance costs. Still, for many households, the lower upfront cost makes cartridge systems a practical, budget-friendly choice, especially if space for installation is a bit more limited. Now, if fluoride removal is also a priority, that's where things get a bit more complicated. The non-backwashing Bodyguard fluoride removal filter, which we added as an additional stage of treatment, is a tank-based system that starts at around $1,300. That higher price reflects the specialized media inside, bone char carbon, which is one of the few proven, more feasible treatment methods to reduce fluoride at the point of entry. Now let's talk about what we liked about these filters, starting with the Magna Compact Cartridge Filter system. It did well, reducing a wide range of contaminants, and its disruptor filter is specifically designed to target lead, which was a key consideration for this install. Since the home was confirmed to have a lead service line, that extra protection was essential. Flow rate is another strong point to mention. With a maximum of up to 25 gallons per minute, this system easily handles typical household plumbing demands without a drop in pressure, which we can confirmed after installation. The build quality is solid as well. The housings are made from durable, high-grade plastic, reinforced with nickel-plated brass inserts to prevent damage from over-tightening, which is a common fail point in similar systems which use plastic connections. And installation was actually pretty simple for a point of entry system, even though the homeowner had very little previous plumbing experience. The install manuals were clear and easy to follow, and have nice color images, not just product schematics. Maintenance should be straightforward, just a few filter cartridges to change once a year, with an estimated ongoing cost of just 1.2 cents per gallon. Now, moving on to the Bodyguard fluoride filter. This system impressed us with its performance, effectively removing fluoride without reducing water pressure. The fiberglass tank feels robust with no flimsy parts, and although installation was a bit more involved, the instructions were just as clear and easy to follow. Maintenance here is practically hands-off. The media only needs to be replaced every 400,000 gallons, or roughly every 3 years. That translates to a very low operating cost, around 0.3 of a cent per gallon. And the lifetime warranty on parts, excluding the consumable filters, is one of the best we've seen in the industry and speaks to their confidence in product quality. Now, let's talk about a few areas where these systems came up short. First, during our initial round of testing, we found that disinfection byproducts, specifically chloroform and bromodichloromethane, weren't fully removed by the cartridge system. Based on our analysis, the likely issue was limited contact time between the water and the carbon media cartridge. In other words, the water was moving too quickly through the filter to allow for more thorough chemical reduction. Now, just to be clear, this isn't an issue related specifically to this product, but an inherent problem faced by all PoE cartridge filters. To solve that, we added an extra carbon block stage to increase what's called empty bed contact time, or EBCT, essentially giving contaminants more time to interact with the media. After that change, a second follow-up test showed full removal of those remaining DBPs. Another downside is the current lack of full system performance certifications. Neither system is certified to NSF-ANSI standards for contaminant removal or material safety as a complete unit. However, I should note that all the individual components do hold material safety certifications from their respective manufacturers. So for anyone who prioritizes verified third-party performance certifications, this is definitely a drawback. That said, I've been told that US Water Systems is currently in the process of certifying several of their filter systems, so it's definitely something that we'll be keeping an eye on. Installation was straightforward in our case, but it still involves cutting into your main water line. If you're not comfortable with basic plumbing, hiring a professional is the safer route, though that does add to your overall upfront cost. Lastly, the lack of free shipping and a limited returns policy were small but important to be aware of. Unless you buy directly through a US Water Systems rep who specs the system for you, you won't be eligible for a full return, which may make some folks hesitate, especially at this price point. So we conducted 2 rounds of lab testing to evaluate the performance of this water treatment equipment. The first post-install test was taken after the initial install of the triple-stage PoE cartridge system. At that point, the system included a 5-micron sediment filter, a radial flow carbon filter, and the lead targeting disruptor filter. In that first test, we saw partial reductions in several contaminants. Chloroform was reduced by 72% and bromodichloromethane by 40%. So even after filtration, both disinfection byproducts were still detected above their respective health guideline levels, and given their known health risks, that was an immediate concern. We also saw decreases in sulfate by 32%, molybdenum by 60%, strontium by 13%, and barium by just 7%. And interestingly, fluoride detections actually increased by 20%. This is likely due to fluctuations of fluoride in the source water between when we took the initial baseline test and then when we took the post-install test 3 months later, as the detection only increased by 0.1 ppm from 0.5 to 0.6 ppm. I should also note that both detections are below the health guideline level of 0.8 ppm. Copper increased by about 6%, and aluminum, which hadn't been present in the unfiltered sample, showed up at 0.063 ppm in the filtered water. Based on the CZF media used, this likely came from the Disruptor's nano alumina fibers, which are made from boehmite, a naturally occurring aluminum oxide hydroxide mineral used in filtration. After seeing these results, we upgraded the system by adding a fourth cartridge, a second carbon block between the existing carbon and disruptor filters to increase contact time. We also installed the Bodyguard fluoride filter as a final treatment stage downstream. One important note here, while the Bodyguard fluoride filter can technically reduce chlorine and disinfection byproducts on its own, doing so uses up its fluoride reduction capacity more quickly. That's because the bone char media inside the filter has a finite number of binding sites. If those sites are used to remove chlorine, VOCs, or other organics, there's less available for fluoride. By placing it after the carbon cartridge filters, which handle most of those contaminants, the Bodyguard filter can focus almost exclusively on fluoride. This not only improves performance, but it also extends the life of the media. The second post-install test, taken after this upgrade, showed significant improvements. Both chloroform and bromodichloromethane were completely eliminated. The aluminum previously detected was gone, and copper, molybdenum, and fluoride were all completely removed as well. We also saw additional reductions in sulfate by 55%, and strontium by 52%. This suggests that extending contact time with carbon and placing the fluoride filter last helped improve chemical reductions across the board. Interestingly, we also saw reductions in minerals, including magnesium by 50%, sodium and calcium by 38%, and potassium, which was 100% removed. Though this in part may also be attributed to fluctuations in the source water between when each test was taken. Overall, the results confirmed that while the original cartridge setup offered good baseline protection, the system upgrade provided the kind of broad spectrum performance we were aiming for. So is this combination of US water systems point of entry filters a smart investment? Based on our testing, I'd say yes, but making sure it's configured properly for your water quality and flow rate is key. What really stood out with this project is how much performance improved when we extended contact time with the carbon block filters and carefully staged each step in the treatment train. Disinfection byproducts like chloroform and bromodichloromethane weren't fully removed until we added a second carbon filter to increase EBCT, or empty bed contact time. That change gave contaminants more time to interact with the carbon media, which made all the difference in achieving complete removal. I also want to reiterate that staging the bone char fluoride filter downstream of the other carbon filters will drastically improve its longevity and efficiency. While bone char can reduce chlorine and other organic compounds, doing so uses up its fluoride reduction capacity faster. By pre-filtering with carbon block filters, we're allowing the bone char carbon media to focus almost exclusively on fluoride, which not only improves results, but should also drastically extend the media's lifespan. I'd recommend the Magna compact cartridge filter system to anyone looking for a lower cost cartridge-based alternative to large tank systems, especially if you want easy maintenance and flexibility. But if your water has higher levels of disinfection byproducts, you may want to size up your carbon media bed from the start, whether that means adding an additional cartridge or going with a tank-based system instead. And the Bodyguard tank filter is a solid option for anyone looking to reduce fluoride for the entire home. Now, if you only want to remove fluoride from your drinking water, a point of use filter would be more affordable. But if your goal is full home protection from every tap, the Bodyguard is one of the few systems that can feasibly and reliably do the job. Whole house treatment systems are not plug and play, but when they're thoughtfully configured with the right flow rates and media volumes, they can deliver excellent results, as our testing for this project clearly showed. If you're leaning more towards a tank-based system instead of cartridges, especially for better VOC and disinfection byproduct reduction, I've also tested the Springwell CF whole house filter, which uses a much larger bed of catalytic carbon. It's a great option if you want more capacity, less frequent maintenance, or if your water is disinfected with chloramines. Click or tap to check out that review and see how it compares.